So last time we studied integration. Chapter 5, and I think I covered 5.2 was just the definition of integration, and I think antiderivative, then substitution, then 5.56 was about definite integral. So now we are moving on to some applications. So I'm skipping 5.7, 5.8, this one. 5.8 is the average value of a function, and we can just go directly to this definition which is written here, 386, page 386. If f is a continuous function on AB, then the average value, also known as mean value, mean is used for the average, is defined to be this one. So if we have average value of f over the interval a to b, if this is the case, is written as FAVE, f average, just short for the average, AVE, is equal to, what we do, we integrate from a to b, fx dx, and then we divide by the length of the interval, which is b minus a. So see, this is the interval a to b. So if you want to find the length, so this length from here to here will be b minus a, right? You can subtract the smaller value from the bigger one to get the length of the interval. So we are dividing by the length, and this gives you the overall sum over the function x, fx. Okay. Remember we said this integral symbol is basically elongated s. You write s like that, right? But if I pull it from both the corners, right, if I pull it up and down, it will become something like that, right? So this symbol looks like an s, elongated s. So the reason is this gives us the sum basically, or we can say that the continuous sum. If you want to add something continuously, not for 10, 15, 30 values, but infinite many values. So let's say if you are given a function y is equal to f of x, now function value at one point from a to b, if I take any x here, this is the value of function, right? F of x. This value is f of x. So basically this vertical line is f of x. And x can take all the values between a and b. So there are infinite many values from a to b, not just few values. If you are going from 1, 2, 3, 4 up to, let's say, 10, then this is not a continuous set of values. This is a discrete set, we call it, right? Discrete set of values, because we have just 10 numbers from 1 to 10. If I want to add my function at this number, no issues. I can find f of 1, f of 2, f of 3, f of 4 up to f of 10. We can add this, right? So this is called a discrete sum. You took the sum of function values over 10 values only. We can do that, no issues. But if you are adding something over the interval, a continuous interval, I don't know how many values are there, because between every two real numbers there is another real number inside, right? So these are infinite many values. I cannot add something like that. Starting from fa, then what is the next value? Whether it is 1.1? No, it can be 1.01. No, it can be 1.001. So there are infinite many values, and if I want to add my function at those infinite many values, right, it's not possible. How can I collect all of them? So what we do, we integrate our function from a to b. It means now I am taking the sum of all function values from a to b. Okay, so continuously, no value is missing. So this is the reason we have this s type integral symbol, because it's related to the sum of the functions. Okay, and you know that now if fx is positive, if fx is greater than equal to 0, this integration gives you the area, right? Because we are adding all these lines, we are adding these infinite many lines, you see. So it covers the whole area up to b. So this gives you the area. Now we are dividing this area over b minus a. So that's the average value. So average value will be somewhere in the middle here. Okay. Function starts from fa and it stops at fb here, right? So the average value will be somewhere in between here. Somewhere here will be the average value. Okay, between here. So if you look at this one, from this expression, you can write this as, if I multiply this b minus a here, it will become b minus a into f average, right? That f average value. Now if you look at these two, these are the two numbers. Average value is a number, b minus a is a number. B minus a is the length of the interval, a to b, b minus a is the length here, right? And average value is somewhere here of the function. So this is the length of average value, this is your length of the interval. So it means it gives you the area of this rectangle, whose height is the average value and width is b minus a. You know that whenever we have a rectangle, length into width, if I multiply length by width, it gives you the area of the rectangle. So here I am multiplying this length, this has become the length, and the width is f average. So this is the width. So if I multiply b minus a with f average, it gives me the area of this rectangle. So the area of curve, area of the curve here, maybe it is like this. This is your y is equal to f of x. So area under this curve, right, this is the area under the curve, blue area, right? And area under the rectangle, they are the same. So if you make a rectangle at the average value, this was the average value. If you calculate the average value and make a rectangle, the area of this rectangle and the area under the blue line will be equal. Okay, so means you are gaining something here, because this area was not included in your blue line. You got a gain, but you lost something from here. This blue area was included, but you are only calculating this here. So this gain and loss are exactly equal. The extra portion that you are getting on the left and this portion which you are not getting, they exactly match if you take this point at the average value. Okay. So that was just an interpretation of the average value. If a function is given and you have to find that average value, it's not an issue. For example, he said, find the average value of the function over the interval 1, 4. Okay, so this is the function. So if I find that, let's say fx is square root of x and your interval is from 1 to 4. Yes, from 1 to 4. If these two things are given, so how I can find the average value? My f average will be 1 over, my interval is 1 to 4, so it will be 4 minus 1, the length of the interval, and I will integrate from 1 to 4 my function. Agree? Why? Because here a is 1, b is 4, and fx is square root of x. So if I replace the value in my average value, it was 1 over b minus a, so 1 over 4 minus 1, a to b square root of x dx, fx dx. That was the formula. So now I just have to integrate this. So it will become 1 over 3 outside and square root of x, x to the power 1 by 2. becomes 3 by 2 over 3 by 2. This is the integration, and from 1 to 4. Because x to the power 1 by 2 has the integration plus 1 divided by 1 by 2 plus 1, right? That's the integration. So that 1 by 2 plus 1 is 3 by 2. So I wrote it directly here. Now we put the upper limit minus the lower limit, right? If I put the upper limit here now, and then the lower limit. So this will become, I can write 2 by 3, 2 by 3 outside, 1 by 3 is outside, this is 3 by 2, but if I bring it out, it becomes 2 by 3, right? Because it's in the denominator. So now if you replace 4 in here, it becomes 4 to the power 3 by 2 and minus 1 to the power 3 by 2. I just want to use this color so that you can, so see this, sorry, 4 is replaced here, and minus, why my pen is minus 1, so this 1 will go here. So first the upper one, then the lower one, right, for x. So now if you it's 2 by 9, 4 to the power 3 by 2 should becomes 2 square, 2 is gone, so 8 minus 1. So 14 by 9 is your answer. Right? So 14 by 9 is your answer. Now they asked us another thing. He said, find all the points in the interval at which the value of f is the same as the average value. Right? So it means what they are asking, the next thing, next they are asking find, this is not the part of average value, it's the second question in the example, that find x such that your function becomes the average value, such that your fx is equal to the average value. Is that, give me the value, this is square root of x, give me a value, let's say this is the average value 14 by 9, right? So he wants me to find this x. What is this number where you are getting your average value, right? So I can just put my fx is square root of x and average value is 14 by 9. So I can take the square on both sides. So x will become 14 by 9 square. Agree? So that will give me the x value. So 14 by 9 square is 196 by 81, almost 2.4. Okay? So almost 2. So this value is almost 2.4, which gives me the average value. So we found the average value, but they are looking for x, which x gives you the average value. So it's an extra question. If they only ask you the average value, you don't need to do this. Okay, so page. Now this was very easy. Anything else here? So look at this one. These are the questions. Find the average value of the function over the interval. So if any value is given, you can easily find that. For example, question 5, sine x from 0 to pi. Exercise 5, page 388. So function is given sine x and interval is given from 0 to pi. So the average value of my function will be 1 over b minus a, pi minus 0. Agree? So, and from 0 to pi, function sine x dx. Simple formula. So now we know that 1 over pi, sine x has the integration minus cos x. So from 0 to pi. Now you put pi and then you put 0. So 1 over pi, when you put pi, it's minus cosine pi and minus plus, because minus from the formula and minus from here. So minus minus will become plus cosine 0. Cosine 0 is 1 and cosine pi is minus 1. So 1 plus 1 is 2. So this answer is 2 by pi. 2 by pi. So that's the average value of sine x over the interval. If I change the interval, average value will change, right? Because this pi minus 0 will change, 0 to pi will change. If I say find the average value of sine x from 0 to pi by 2, answer will change, right? So this was kind of an application of integration, right? So we are more concerned with application. Sometimes in calculus 1 we teach this section, but now maybe a couple of years ago this course was not there, applied math was not there. So then we try to teach more applications in calculus 1, but now they have this separate course, so we don't concentrate on applications when we are teaching calculus 1, right? So maybe Dr. Badriya did not teach you this one. If she has done it, I'm not sure. So anyway, let's go to 5.9. 5.9 is again from calculus 1. It is again a technique of solving integration. In 5.3, we used substitution to solve it, right? Remember when you have, we did this in section 5.3, that when you have integration of some function and another function is given inside a bigger function, but you have the derivative of this inside function. Derivative of this inside function is given without f, right? Then what we do, we use substitution. U is equal to g of x. If I replace u as g of x, then du becomes g prime x dx. So my integration changes to f of u, and this whole thing becomes du. So see, this is much easier than integration before. This is what we did in 5.3. In 5.9, we have using a substitution for this type of functions. For limits, here there are no limits, you see. For definite integrals, let me write this. Substitution using for definite integrals. Definite means when there are limits. Okay, so if the limits are given from a to b, and you have the same situation that you had in 5.3, then what is the change here? I will still look at some function whose derivative is given with d of x. I will still look for that. Okay, so I will substitute, we will substitute u is equal to gx. So du will become g prime x dx. Okay, so here I will get integral of f of u du, because this gx becomes u, right? And this whole thing becomes du. Agree? Now what's the difference? The difference is, here when you use substitution, then you integrate. You integrate this one and you get capital F of u plus c. And then, because my function, my original question was in x, this question is in x, so my answer should also be in x. So what we do, we replace our u is equal to gx in my final answer, and that's my answer. We replace u back. This is what we did in 5.3. But here limits of x are given. X is from a to b. I changed my question from x to u. So it means I should change the limits as well. Now I cannot write it from a to b. This is the issue. The reason is, my u may not be from a to b. It's a different case now. So what we do, I will replace x is equal to a. So u will become g of a. I will replace the value of x here. When x is b, my u is g of b. Right? So let's say this new number is c and this new number is d, because g of a and g of b are the numbers. Right? So what we can do, we will replace this from c to d. Because this is x and we had the limits of x, a to b. And now we have u, so it's you should have the limits of u. U is from c to d. So I will change the limits. Now if I integrate this, I get f of u. But because it's a definite integral, when we integrate, we just put the limits from c to d. And now I can replace the limit inside f of d minus, now we put c, so f of c. That's my answer. That's it. So it means I don't have to go back to c now. X, sorry. I don't have to go back to x. You see here, at the end I replace u by g of x. Here I don't need to do that. Reason is that I took the limits with me. Now I don't need to go back to x, right? We have moved permanently. So see, my x was from a to b. So when I use the substitution u is equal to gx, now I am not in x. This was my x-axis, but now my new axis is not x-axis, it is u-axis. So this a may become a c here, and this b may becomes a d here. Okay, so we have moved everything. I have come to this territory now. I will just integrate from here to here. Okay, so no need to go back, just find the answer in C to D. So let's see an example. 0 to 2 x square plus 1 cube. One thing is that I can open this cube and multiply x inside integrate. No need to find substitution, right? But we know that this function, inside function x square plus 1, has the derivative 2x. 2 is not a problem for us. As long as the variable part is there, we can use substitution. So let me rewrite it first. I can write because we write this big function first, and then whatever the derivative of this function is, we write it with dx. So I can write x with dx. I can do that. Now substitute the inside function whose derivative was with gx. So u is equal to x square plus 1. If I take the differential, it becomes the derivative is 2x with dx. But I only have x dx here, no 2 is given. So no problem. I can divide 2 on the other side and write x dx. That's why we said constant is not a problem. If constant is missing, no need to worry about. Constant is missing, no issues. But if x is missing, then we have an issue. If this x is not there, then we have an issue. Okay? So anyway, now I can replace, this becomes u to the power 3 because x square plus 1 is u, and x dx becomes half du. But we have the limits here from 0 to 2. It means I need to change the limits as well. This is my u, so I will use the limits. My x is 0, the lower limit x0. x0 will give me u is equal to 0 square plus 1, which is 1. And when x is, second limit is 2. When x is 2, my u will become 2 square plus 1, which is 5. So my limits are from 1 to 5, not from 0 to 2. Got it? We have to change the limits. Now 1/2 is a constant. I can write 1/2 outside, and this is what we have, u cube du. Now in the integration of u cube is u to the power 4 by 4 from 1 to 5. So now I will replace this 5 first and then 1. So it will become 1 over 8, 4 2s are 8, and u4 means 5 to the power 4 minus 1 to the power 4. 5 to the power 4 is, I think, 625. 5, 5, 25, 125, 625. So 625 minus 1, 624 by 8. Okay. So 78. So that's the integration. And see here, I did not replace my u back. U was x square plus 1, right? But no need to substitute. No need to substitute back. Right? Why? Because we have the limits for u now. We have limits for u. Right? and we can directly replace those limits 5 and 1. These are the limits of u. No need to go back to x. We have brought our limits with us, right? So as if you bought a new home, you brought all your stuff with you, right? Now you will not go back. You brought your limits, you brought everything with you, right? But if you are not moving permanently, you are going to visit some place, you did not bring everything with you, so you have to go back. It's same situation like that. When you were in 5.3, I did not bring anything with me. I only substituted, did my thing over there and went back to x. Okay, so whatever we have to solve, go back. So let's see if we have anything from the exercises. Uh, Something challenging, difficult. Let's say this one. 0 to pi by 4 tangent secant square. Exercise 38 on page 394. So integral from 0 to pi by 2 square root of tangent x and secant square x dx. Now you know that this is a big function. Square root of tangent x are two functions, f of g of x, right? This is your f of gx, and gx is tangent here, right? And then the derivative of tangent is secant square. We know that that is secant square with dx, right? So we have the scenario that we are looking for. So it means I can substitute tangent x without square root inside function. Square root is my f is square root, gx is inside. Okay, so don't put square root here, just inside function. U is equal to tangent x, and the derivative of u is secant square x dx. So now you see this will become, so this will become 0 square root of u, and this whole thing becomes du. Agree? See, this is secant square dx is du. So secant square x is du. Now I had to change the limits because these are the limits for x, and I have to find the limits for u, not just x. So we can look at x is equal to 0, gives me u is equal to what? Tangent 0. U is tangent x. So when x is 0, u is tangent 0, which is 0. When x is pi by 2, tangent pi by 2. Is it pi by 2 or pi by 4? Pi by 4, right? So the reason I realized that it should not be pi by 2 because tangent pi by 2 is not defined. Tangent pi by 2 is infinity. So that's why I was confused why it is tangent pi by 2. It is tangent pi by 4, which is 1. You can use calculator. Tangent pi by 2 will not be any answer. Okay, tangent goes to infinity when x is pi by 2. So now we have the limits from 0 to 1. When x is 0, my u is 0. But when x is pi by 4, u is 1. You see here? When x is pi by 4, u is 1. So limits are changed. Okay. So now I will integrate. What is u? This is u to the power 1 by 2. 0 to 1. Square root of u is this. And if I integrate, it becomes 3 by 2. 1 by 2 plus 1 divided by 1 by 2 plus 1. And I have to use the limits from. Now, no need to go back to x because I have the limits of u here. So we can directly put the limits. So 1 to, so this 2 by 3, 3 by 2 will become 2 by 3, right? And this will become 1 to the power 3 by 2 minus 0 to the power 3 by 2. So that is 1 only. So 2 by 3 is the answer. Okay, so that's how we do the because we will have and our aim is to do chapter 6, right? So chapter 6 will have lot of integrations over there. So if we don't know the integration, we will be in trouble, right? uh, so this is a challenging question, but maybe I can do that. You see here, he said uh, use the identity to find that. 0 to pi by 6, it's an interesting question. Let's do that. 0 to pi by 6 sine 4x and cos cube x dx. You see, if this cube is not there, it's very easy question. Why easy? Because I know that the derivative of sine is cosine, right? So what I will do, I will just substitute u is equal to sine x, because I know that if u is sine x, it becomes u to the power 4, and du will become cosine x dx. So this whole thing will become du. So it will become very easy, right? So, but the problem is they did not give us cos x. They gave me cos cube x. Now this is the issue. If I take u is equal to sine x, I only need cos x, not cos cube x. So what should I do? So at least it gives me some idea. It tells me that it's okay, you don't have cos cube x. So what I can do, I can write this cos square, cos cube as cos square x into cos x. Can I write that? Cos cube is the product of cos square into cosine. We can do that, right? So now see, this has become du. So this becomes du, but my u is sine x. This becomes u4. So inside function is left. So what should I do with this one? U is sine x. I don't have cos square x. So we know that the cos square x can be written as 1 minus sine square x, right? Because sine square x plus cos square x is 1. Remember this identity? Sine square plus cos square is 1. So I can bring sine square x on the other side. So it will become 1 minus sine square x. So that's what I will replace here. Then I will have no trouble. So 0 to pi by 6 sine 4x, and this cos x, cos cube x will become, which was the question mark, it becomes 1 minus sine square x, and this remains as it is, cos x dx. Now I have no issues. Now this substitution will help. Now this substitution will give me u to the power 4. This will become 1 minus u square, and this will become du, right? And 0 to pi by 6, I have to change the limits now. When x is 0, my u is sine 0. Sine 0 is 0. When x is pi by 6, why they gave me pi by 6? Okay, no problem. So pi by 6 is sine pi by 6. Sine pi by 6 is sine 30. Sine 30 is 1 by 2. Okay. If you use sine pi by 6 in the calculator, you have to be careful. Okay. It may give you a wrong answer. Reason is that in calculator, if your calculator is in degrees, there is a small d written over there. Okay. Then you have to use sine 180 by 6, because pi is 180 degrees. Okay. So that is sine 30. That will give, calculator will give you 1 by 2. If you write sine pi by 6, it will not give you 1 by 2. You can check that. So what you will do then, if you want to use pi, then you have to change your calculator to radians. Is it 1 by 2? Right? So see, now if your calculator in radians, if you want to use sine pi by 6, then you have to convert your calculator to radians. Shift or mode. If you press mode 2 times, you will see DEG or AD, degree radian. If you press 2, it will change your calculator to radian. You will see a small r over there on the top. Now you can write sine pi by 6. You can press pi by 6, it will give you 1 by 2. Same answer. But in degrees, if you write sine pi by 6, that will be wrong. In degrees, if you write sine pi by 6, it will give you a wrong value. So you have to be careful, okay? So now it will be 0 to 1 over 2. So how to integrate this function? Can we integrate? We cannot integrate directly. So what should I do? I will multiply u square inside. First, u will multiply by 1. It will give you u4. And then it will multiply by u square. It will give me u6. Now I can integrate. u4 becomes u5 by 5 minus u6 becomes u7 by 7. Agree? So now I will put the limits from 0 to 1 over 2. So now if you replace 1 over 2 to the power 5 by 5 minus 1 over 2 to the power 7 by 7. Then minus 0. 0 will give me 0. Right? 0 by 5, 0 by 7 will give me 0. So whatever is the answer, just write that. Yes. So this is what I was saying. When you use degrees, right, it will give you the wrong answer. You cannot write pi when your calculator is in degrees, right? Yeah. So then pi means 180. Then you will put 180 degrees here. 180. Okay. Now it gives you 1 over 2. If you want to use pi, you have to change it to radians, I guess. Shift mode. You see this is radians. Radian is 4. So press 4. Now you have an R here. Oh. So now if you write sine pi by 6, you will get the same answer. Sine pi by 6, right? It gives you the same one bit. Oh, okay. So this is what I was explaining. That if you are writing pi, then it has to be in radians. Otherwise, use pi is equal to 180. So it's better to use pi 180. Don't change your calculator. Now change it back to radians. Otherwise, in other calculations, you will have problem. Press shift mode. Then it gives you the radian. I think 3 will be the radian. Press 3. This is a common mistake students do. That's why I used to do that. So this is from chapter 5. These are the things that we will need in chapter 7. 6. 7 is again, we have it in calculus 1. So when you had your in 5.2, 5.1 and 2, in 5.1, 5.2 both, they give me the area under the curve. Area under the curve. So if your curve lies above x-axis, if your curve is above x-axis and you want to find the area under it between the values a and b, this area was equal to a to b fx dx, right? This was what we studied over there. Here fx is positive on AB and fx is continuous on AB. These are the two conditions. Your function should not have any break in it, okay, and it has to be above x-axis. We can extend this concept to functions of 2 between two curves, right? We can extend this to idea to find area between two curves. Between two curves. So what is that? If one function is y is equal to g of x, the other function is y is equal to f of x. Let's say these two functions are given, two curves are given, and you have from A to B, let's say. This area you want to find. Area between two curves from A to B. right? So how to get, you can do that. So here the conditions are, your fx should be greater than gx, means fx lies above gx in the whole interval on a to b. In the whole interval, it means that fx lies above gx throughout the interval, okay, over the interval a to b. So they are not changing their positions, one remains above the other. If this is the case, and now there is no condition of positive negative, your gx may be negative, no problem, okay. We only need this condition, and both are continuous functions. Second, this is the first condition. Second is both fx and gx are continuous on this interval a to b. Means continuous means no break, right? There is no break in our functions. Uh, so then area between the curves, or I can say that then the area of region enclosed by the curves y is equal to fx, y is equal to gx, and lines on the sides x is equal to a and x equal to b, right? On one side you have x is equal to a, because the vertical line, this vertical line has x is equal to a, and this vertical line is x is equal to b. So when you have x is equal to constant, it's a vertical line. When you have y is equal to constant, it is a horizontal line, right? So these are the lines instead of curves, horizontal line. So we have on the sides, on the left and right, we have the lines x equal to a and b. So this area is given by a to b fx minus gx. So we subtract bottom curve from the top curve and integrate. This is it. Uh, you can see that here, if I have one curve above and the second is below, if I only integrate fx from a to b, right, I will get this whole area from x-axis to fx. The second curve is gx, this one. If I integrate gx from a to b, I get this area, the bottom one, right? So if I subtract the black one, red one from the black one, I will get this blue one which is between a and b, right? So see, if I subtract red from the black one was a big area, and we subtracted the red and we got the blue one, right? And this blue one is actually what we are looking for, area between curves, which I wrote a to b fx minus gx dx. This is what I wrote, that this is the area. Now if you just write the area of black curve from the previous exercises, we know that if I only integrate fx, it is the area from here to here, total one. And then the red one is, if I only integrate gx, because this curve, the red one is gx. So if I integrate a to b gx, I have the red area. So see, when the limits are the same, dx is the same, limits are the same, it means I can subtract fx and gx and then integrate. So see, the left hand side is actually equal to the right hand side. So this is the idea. We are subtracting the smaller area from the bigger one to get the inside area. Okay. So that is a very simple, basically, application of our. So here it is written. So if your fx remains above gx, both are continuous functions, then the area of the region bounded above. So this is the top curve and this is the bottom curve. Above minus below, top minus bottom. So that's how you can remember the formula. So this is the top curve and minus the bottom curve. Top minus bottom and integrate. Okay. So let's see. Find the area of the region bounded above by x plus 6 and bounded below by y square and on the sides by 0 and 2. So see, upper curve is x plus 6, lower curve is y is equal to x square. Usually we think that x square should be above because x square is a bigger thing, right? And x is a smaller thing. But if you look at from 0 to 2, x0, x2. So these things are given. If you draw the curves at 0, this is y is equal to x. Y is equal to x. If I add 6 in it, it means I have to bring it up 6 units here. So this will be the curve, the same curve, y is equal to x passing through 6. So that is my y is equal to x plus 6. That's how I can draw this. That is y is equal to x plus 6. Now we all know that the y square curve is this one. This is y is equal to x square, right? Y is equal to x square. Now automatically you can see here that at x is equal to 2, this is 4 and that is 8. So somewhere here at x is equal to 2, y is 4 and that is 8. So this is, I think, no, the common point is not this, somewhere here. They intersect at so 2 is somewhere here. Somewhere here. This is x is equal to 2. So from 0 to 2, it means I don't need this left portion, right? Because we are on the right side. So I'm starting from here. So this is the area they are looking for. Between 0 and 2, and see this is the curve above. So this is my top curve and x square is my bottom curve in this region. So I can write the required area as 0 to 2. Top curve is x plus 6 minus the bottom curve is x square dx. Right? Another thing which can be used if you have a shape, if you have a picture, right? So here I had this type of thing, right? You can draw a vertical line anywhere inside the curve. Draw a vertical line anywhere. Draw a vertical line inside the region. Look at this bottom and this top. So basically you want this height. If this top is your f of x and bottom is your g of x, it means the distance, the height is fx minus gx, right? So basically you are integrating this vertical line inside the limit. So see here, we know that this is x plus 6 and this is x square. So basically the top is x plus 6 minus x square. So you are looking for this vertical line inside your area. Inside your area. Look at the length and integrate that length from 0 to 2. So now if I integrate, what I will get? X square by 2 plus 6x minus x cube by 3. Right? And from 0 to 2. So now if you replace 2, it becomes 4 by 2 plus 12 minus 8 by 3. And when you put 0, everything will become 0. If you put 2 here, 2 square by 2, 4 by 2, 6 into 2 is 12, and 2 to the power 3, 8 by 3. But when you put 0, it's 0 plus 0 minus 0. Everything is 0, so no need to write that. So this will give you the answer. 2 plus 4 by 2 is 2. 2 plus 12 is 14. So 14 minus 8 by 3. 14 times 3 is 42. 42 minus 8 is 34 by 3. That's your answer. Okay. Now they change the equation. Same question, x square and x plus 6, you see. What is missing? What is the difference between previous example? Here they gave you the sides from 0 to 2. Here they did not give me the sides. They said find the area of the region that is enclosed by the two curves. This is example 1 on page 416 and example 2 on page 416. Example 2 on page 416. They said find the area enclosed by the curves now. Find area enclosed by the curves. Curves are the same, they didn't change it. X plus 6, which is a straight line, and x square, which is a parabola. Now it means they are intersecting at 2 points. Otherwise they will not enclose the area. Let's say if they give me two straight lines and they say what is the area between these two lines, I don't know, because one line is this, one line is this. They don't enclose any area, right? We have one point common, but where is the second point? So you have to give me some second point so that I can get the area, or you can give me second point here, I can get the area, right? Here they did not give me the second point. It means we have two intersections here. It means one curve is going like that, second curve is going like this. So if you have two intersections, I have the area between the curve. So this is what is happening here. So now I will draw the whole curve and see where they are intersecting. So I know that one curve was x plus 6 and second curve was a parabola like this, right? Y is equal to x square. So now you see I have the area enclosed between two curves. So it means I need this point. What is this point? And I need this point, because these are my limits of x. So I want to know what is this interval, right? So these points will come from intersection. So I have to find the points of intersection. Without that I cannot find that, right? So how I can find points of intersection? I can equate them. You see, y is equal to x square and y is equal to x plus 6. They should be equal, right? I equated y values. So what I did, equate y values. Because at the point of intersection, my y should be same, right? X and y should be same. So from here, it becomes x square minus x minus 6 equal to 0. So x minus 2, x plus 2, x minus 3. X plus 2, x minus 3. Because minus 3 into 2 is minus 6. And if I add, how I got this minus 2 and minus 3? Because 2 into minus 3 gives me minus 6. This one. And if I add 2 and minus 3 gives me minus 1, which is this one. Okay. So let me write it in blue. What's wrong? So let me write this in blue. Minus 1, right? So this sum is minus 1. And let me check the red one. This minus 6 is the red one. So I need this minus 6 as the red one. Product should be minus 6. Sum should be minus 1. That's how we write the limit. So x becomes minus 2 and x becomes 3. So see, this point comes out to be minus 2 and minus 3. So this is now minus 2 and this is 3. What What happened? So I got the limits now. So what is the top curve? Top curve is x plus 6, right? And this is the bottom curve. So top minus bottom, I will have the area. So therefore, the area enclosed by the curves will be from 2 to 3. Limits were not given to me, but I found the intersections. Top curve is still x plus 6 and minus the bottom curve is x square. So still top minus bottom. So now it's simple. You can, I think, integrate and get the answer. X square by 2. The Wi-Fi disconnects and this also disconnects. So let's see if I have. Uh, you can read this one. You see, they give you the criteria. First of all, sketch the region. If you can sketch it, it is very helpful. Okay, and then draw a vertical line segment through the region at any point connecting. So he said, first draw the region, whatever the above curve is, whatever the below curve is, right? So this is the area you are looking for. He said, at any point x between AB, draw a vertical line from top to bottom. Draw this line and see what is the height of this line. These are the tops and bottom, and then you see how far this can go on the left and how far this can go on the right. So these left and right gives you the area, limits of integration. So these left right gives you the limits of integration from A to B, and this top minus bottom gives you the integrand. Top minus bottom comes here. So if you draw the picture, that will be a great help. Okay, and then you can just integrate. So let's say here. These two are the questions, let's see. See, in the first one, my area will be, he said, find the area enclosed. Now, he said, draw a vertical line within the region from -1 to 2, right? So my x is inside here. So on the left, x can go to 1, on the right, it can go to 2. So it means these are my limits of integration. Okay, and then if I draw a vertical line here, what is the top curve and what is the bottom curve? So what do you think the bottom curve is? You see here, this bottom curve is this one and this top curve is this one, right? So this is my top curve, this is my bottom curve. Agree? That's the problem. Okay. So now area will become, top curve is x square plus 1 and minus the bottom curve is just x. Okay. Top minus bottom and dx. This was easy, right? So top curve is this x square plus 1 Bottom curve is the red one. Y is equal to x, and we can easily do that. So that's what he said. Draw a vertical line, see what is the top and bottom, and see now how far it can go on the left and right. So this line can be on the left at -1, can be at the right on 2. So that's your answer. So you can, I think, complete it, right? Integration is not a problem. Here you look at this curve. If I draw, see my interval is from here, this point to 2, right? If I take any x here, this is my top minus bottom. But if I change this curve here, I have different top and bottom. If I change it to this one, different top and bottom. Top is the same, this line is the same, but see, bottom is changing. The bottom line is changing at these two points. One is this one, the second is this one. So here my top is the same in both the points. Top is the same, but you see, bottom curves are changing. Here the bottom curve is this, here the bottom curve is this. So there are two bottom curves. What should I do? Right? I can do two things. One thing is that I can break here at this point 1. I can break the interval and find the area separately. This area separately and this area separately. So I can make two integrals. One integral from this point, which is not given, this point to 1, and another integral from 1 to 2. I can do that, right? So top for both is the same, but bottom is changing. Top is the same, bottom is changing. But instead of this one, if I do one thing, instead of that, if I use y-axis, instead of x, then what will happen? Means take this y is equal to 1 over x square, this curve, right? And the second one was this. So he said, instead of taking with x-axis, you take it with y-axis. Let's say this point, my y starts from here to here, right? And if I take any y inside and make a horizontal line now, and you see what is the top? Top is the right side now, right? And bottom is the left side now, right? So right minus left. Now this distance will be right minus left. So my area will become right minus left instead of top minus bottom, and with respect to y. And then I need the limits of y now. Need the limits of y. Okay, so I know that y goes up to 2 from this point. So this point is the intersection. So what are the curves? One is x is equal to y. The second is x is equal to 1 over y square. So I can find this intersection. This intersection can be found by taking the point of intersection, by taking these together. Y is equal to 1 over y square. Because you see, one is y, the second is 1 over y square. So this has become y cube equal to 1, so y will be equal to 1. So here this number is 1. Y is 1. I don't know why he does not allow me to choose this. So this y is equal to 1 comes here. This is the value. So it means my y goes from 1 to 2. So this is my area. I got this. So when we have x as our integration variable, when we have x, we write top minus bottom, right? When we have y, we write right minus left. So now my right minus left has become, right is, what is the, this one is right. So the right curve is this, x is equal to y minus the left curve. Left curve is this. This is the left curve, right? This curve. This curve is the left curve. X is equal to 1 over y square. So I will subtract x equal to 1 over y square from 1 to 2. So instead of x, if I use y, whatever we were doing with x, do it with y, right? So y limits are from bottom to top, but my curves are from right to left, not from top to bottom. So this will become our integration, and from 1 to 2 you can find that, right? You can integrate and find that. So if you look at these exercises again, 2 is from top to bottom. So this is with x, with dx. 4 is from again right to left, because top to bottom is different. Here top to bottom, here top to bottom is different. So you should go from right to left. It means you can use y here. So same like 1 and same like 2 is 4. So you can try these questions 2 and 4 on page 419. So I can write here, try exercises 2, 4 on page 419. Yes. Okay, so I was recording this session, so I can stop the recording.